Keep in mind all those things you discussed in your group, and it's time to move on and see if we can learn anything extra as we welcome you to Overdriving Your Headlights. I want you to take a minute to think about what that means with what you discussed with your group, but just keep those thoughts in your head right now. Okay, with overdriving your headlights, there are three main things to focus on: your visual searches, your speed, and your braking distances. So bring up our old information, get that in your head, and let's take a discussion break. I know it's quick in the video, but I want us to put all this together right now. And how does night driving change these three things? Very nice discussions we had, and we all focused on review. So we're going to quickly go over visual search patterns so we're all on the same page to set us up for what this looks like at night. So bear with me while I draw my perfect lines. And we're going to continue using that find, solve, and control system we've been talking about through the course so far. First, of course, we find our target area. And I labeled these out of order, but we should know them anyway. I started with that middle one, that 15-second solve area, where you're trying to solve any potential problems or maneuvers you want to make. Then that 15+ second find area, where you're finding those things to solve. And of course, the 4-second control area, where you're trying to control all those things to prevent hazards and the safest of driving. But don't forget that rear search zone. But what does the search pattern look like at night? And here we go. Our day is turning into night. It's not a perfect thing. It's just kind of fun. But it should show a good example of what happens to our visual search at night. Now we're going to check out a video to see what it looks like when you're actually driving. Let's go for a cruise on this highway. This is a average size highway for eastern Montana. What I want you to do is just take mental notes of everything you notice. What do the headlights look like? How far can you see? What does the road do to the headlights? Just sit back and enjoy for a little bit, and then we'll share what you observe. Now you may be noticing that there's almost like, and we just switched to high beam headlights, and it clearly goes much further down. But there's almost like a wall of black that you drive in, especially on the low beams. So we need to start considering how much distance we have inside those low beams. These headlights are probably average on an average car, and the NSTA says that on low beams you should be able to see about 160 feet ahead of you, and then about 350 feet ahead of you with high beams on. Now there's a vehicle approaching, and I want you to make mental notes on what it appears like as we pass a vehicle with headlights. That actually wasn't too bad. It's a little worse on our own eyes. Maybe this upcoming one's a little worse. It's harder to see than the camera takes in things. Okay, that last one was pretty good. But you'll find that when you're driving and you're passing headlights, it will block your vision for a little bit. Like, you'll get even less vision than what you see with low beams on. Keep that in mind. But to get back to my discussion on headlights, if there are low beams, we can see about 160 feet ahead of us. But when you're driving 60 miles an hour, you're going about 88 feet per second. So think about that. How many seconds am I giving myself on low beams driving that fast? It's about 2 seconds. And you kind of want to think of night driving as that 4 second zone. That wall, especially with low beams, you want to treat that wall like you're at 4 seconds so you can have your best response time, that safety zone. It's obviously a little bit better with high beams on. So when it's high beams, then you're getting about that 4 second distance, because 88 times about 4 is about 360. Keep that in mind as you keep watching for a few more seconds. Some other thing to point out as you're watching this, not all vehicles have the same kind of headlights or quality. It's actually getting very complex with the technology. This is an average vehicle, as I said. So some vehicles will be able to see further on both headlight settings, or if it's older or not clean, or depending on the roadway, which you'll actually see later, you're seeing less down the roadway because of the headlights. So just continue taking everything in. Now, even though we can't really find a target area, we can do a similar search pattern. Like, you're looking into the darkness, but you can see some things that are 15 plus seconds ahead. The reflective things. So take that in. How is that important? Also, see what the headlights are doing on the roadway. This is a more even roadway. Does that impact headlights? Keep that in mind as you compare it to other road surfaces we'll be on. So start taking in things with other perspectives. We're now in a passing lane, a passing zone. How far to the right can you see? Now, how far to the left can you see? Can you see the entire roadway to the left? These are low beams again. Let's see what happens when it goes back to high beams. How much improvement was there to the left and the right? Or was it all further down the road, ahead? Also, don't forget to be checking your rear zone. If there's nobody behind you, you won't be able to see anything, but think about what you will be able to see. Remember, I said you need to consider that 4 second safety zone or following distance in the night. So we're going to use these arrows when I can first see them. 1, 1,000, 2, 1,000, 3, 1,000. Yeah, so I hadn't even gotten to 3. So even with these high beams on, and the speed this driver is going, which is about 65, the high beams don't seem to be illuminating as far as they should, which is, remember, about 350 feet down the road. That could be due to being dirty or just being an older vehicle, but also the driver going about 65 miles an hour is going faster than that 4 second distance. Remember, at 60 miles an hour, you go about 88 feet per second. So that extra 5 miles an hour does change quite a bit. So just keep that in mind, that very small amounts of speed changes how far you can see ahead. That's enough highway watching for now, but there are many other types of roads around our area. So keep in mind of all the notes you took. We're going to look at one more. We're going to look at paved county roads and then we're going to take a discussion break to talk about and compare and contrast the two road surfaces and how the lights appear. Here's another roadway. Looks like a highway, a narrower highway, but it is a paved county road. But on this one, compare it to the highway and pay special attention to different things that this roadway has on it to help you drive safer. We've been watching clips of roadway driving for far too long. We need to take discussion break number 2. So check in with a neighbor or anyone around you. Recall what you worked on in the opening activity and what you observed with your mental notes. Then you're going to combine all that, try to answer these questions. First one, how do low beams and high beams compare? Then you're going to discuss how do headlights appear on the different roadways, and then how do headlights affect visual searches. We'll erase that mistake. And finally, we're going to reflect on the very last part of that last section. How does roadway technology help with night driving? Hey, welcome back from break discussion. I really like what we're talking about. We're really coming up with some good things. I hope we can keep in mind that those roadway surfaces really do help the headlights for vision. Because in the next few, you're going to see that certain roadways actually reduce our vision ahead. And you'll see what I mean in a minute. Also, just always consider that those signs are designed, those reflective signs are designed to help you prepare. Like in that last clip, those signs helped us see the upcoming stop sign in our 15 and plus second range. So that technology helps us not always have to be ready to predict in our 4-second zone. Yep. So now we're going to watch some more videos of similar county roads that are paved, then a narrower one, and then some gravel county roads. So take some more notes on what all this looks like, and then we'll move on to braking distances, and I'll set you up for an activity. We're almost done. So here's some more paved county road driving. Similar to what you saw before, you can see those signs lighting up way ahead. And those markers in the center lane give you clues onto what the roadway's doing. It helps you predict what's coming up because it reflects past what your headlights can see. Take another note of like how far left you can see. Can you see the whole roadway on this road? How far right can you see? Where do you think you could start spotting animals at? Consider those things. Keep watching for a few. So the high beams just came on. Keep watching for a little bit. How far left now? How far right? Or is it mostly just ahead? Then we'll switch in a few seconds. Here's a good illustration of what those centerline reflectors do. It's showing you that it's curving in by how much. Whereas if those weren't there, you'd really have to be focused on that as you're going through it to do it successfully, and that takes a lot of your vision away from the rest of the road. But it allows you to look far further ahead to see that. And yeah, the high beams even illuminate them even further than the low beams do. Here we are on a different county road. This one's much narrower. See what that does with the headlights. And check out the difference between high beams and low beams. This roadway has a whole different feel to it, and you'll notice this when you're driving. Different roadways feel like they interact differently with your headlights. So keep taking mental notes to share for later. You'll also notice that this one does not have those center line reflectors. So we have to pay way more attention to what the roadway's doing because there's no clues coming our way. And finally, we have our gravel road, county road. Now, there's almost nothing reflecting in this. So just take some more mental notes. How do you feel about this one? How does it compare to the highway, the paved county road, and then the narrower paved county road? As you continue to watch this for a little bit longer, consider other things. Like this driver just came up to that turn and made an easy turn. Why did it not feel too sudden, this turn coming up? Why is that? Why do each of these surfaces require different speeds to prepare? Are the braking distances the same for all of these? And let's come to a sudden stop. And let's look at this graphic. It's not perfect. It's just to get you to think about how fast you're traveling in feet per second at different speeds. So we're on low beams on this gravel road. That means we can see about 160 feet ahead of us. If you're driving 25 miles per hour, you're traveling at 37 feet per second. 45 miles an hour, 66 feet per second. 65 miles an hour, 96 feet per second. And 75 miles an hour, so like in between interstate and highway speeds, you're going 110 feet per second. But now remember, it's not about fitting inside of that light. We got to think about that 4-second safety zone following distance we keep referring to all year. And remember that it takes a little over a second to a second and a half to react to something. That's processing what you see, making a reaction, and doing the reaction. So let's look at this. At 25 miles an hour, you have 4.3 seconds. So that's right in that zone. At 45 miles an hour, you have 2.4 seconds to travel that 160 feet distance. At 65 miles an hour, you have 1.6 seconds. And at 75 miles per hour, you have 1.4 seconds. So at 65 to 75 miles an hour, you're covering that 160 feet and only having time to process and begin to react to whatever you see at where that end of that light happens. So just consider that when you're driving those speeds with low beams. We're going to look at what this looks like with high beams on a highway, and then we'll discuss stopping distances. So with that 1 second of reaction time, or that 1.5-ish, so imagine there's a turn right on the edge of those where the headlight ends, and you have 1 second at 65 miles an hour to respond to that, or even at 45 miles an hour. Now you have enough time to respond, but about a second to react, to like maneuver. So consider those things. Maybe there's a deer there, or a person walking, or a vehicle without headlights. Just keep those considerations in your head as we move on. Okay, now we have a highway with high beams on, so we can see about 350 feet down the roadway. The speeds, if you were going that speed, and the feet per second of those speeds stays the same. So 25 is 37 feet per second, 45, 66 feet per second, 65, 96 feet per second, and 75, 110 feet per second. So what we need to continue discussing is that 4-second distance. So at 25 miles an hour, you have 9.5 seconds until you get to that spot where it says 350 feet. At 45 miles an hour, you have 5.3, so still above that 4 seconds. At 65 miles an hour, you have 3.6 seconds to get there. So now we're under that 4-second distance. And at 75 miles an hour, you have 3.2 seconds until you cover that distance. So it's not as intense as with low beams, but you can see that at even nighttime highway speeds at 65, you're running just short of that 4-second distance. So any faster than that starts to get really dangerous on reacting to things that come up. Okay, just keep that in mind as we move on to braking distance review. Okay, now it's time to talk about braking distances. This chart that just popped up refers to the full distance as stopping distance. This chart is from the NHTSA, or the National Highway Transportation Safety Administration. There, I got it. And it's trying to illustrate stopping distances compared to headlight distances. So this first vertical bar, this light purple color, says 160 feet on it. So we know that's low beam distance. For some reason, they did not put the high beam distance on it, but on the bottom horizontal blue bar, it goes past 310, so slightly past 310 would be our next vertical bar. Maybe even about where those dark blue squares are, you could connect those and call that roughly 350 feet. But an interesting thing they included for you to also consider, and we brought up earlier, is reaction time. They are saying reaction time is 1.5 seconds, which we discussed before. Sometimes it's quicker in people, sometimes it's a little slower, so 1.5 is a good number. So if you're traveling 20 miles an hour, this chart says that your reaction distance in feet per second is 44 feet. Then your braking distance after you choose to react is 25 feet, making a total stopping distance of 69 feet. So the faster you travel, the further your distance is in reacting, the further your distance is in braking, and the further your stopping distance is. So let's kind of look. They put on that vertical bar for 160 feet for your headlights. They kind of, to illustrate hazards, they kind of put some images here. So like there's the trees. What is that, a bunny or something? So at 40 miles an hour, according to this chart, your reaction distance is going to be 88 feet. Your stopping distance is going to, or your braking distance is going to be 101 feet. And your total stopping distance is going to be 189. So according to this, if you're traveling 40 miles an hour and you have low beams on, you will not have time to stop and not hit this in your way without evasive maneuvering. And we want to prevent a situation for evasive maneuvering because that puts our vehicle out of balance and it makes us react, and we'll probably overreact. The danger just greatly increases. So let's take a look at one more. Let's look at the 70 miles an hour. It looks like, I can't tell what that is, an animal in there. There's something. But anyway, at 70 miles an hour, your total stopping distance is 464 feet. Your braking distance is 310 feet. But your reaction is 154 feet. So according to this, you didn't even react by the time that object came into your headlights. You couldn't even make it evasive maneuvering. So just keep these things in mind as we continue building our sense of overdriving our headlights. It's that time again to take another break, our final break for discussion number 3. You're going to apply everything you've learned from your discussions to your observations, to anything else that you listened to in this video, and you're going to put together everything we have discussed to come up with a definition or description of overdriving headlights. Okay, you're going to now, after you've come up with this definition, I like what we've been discussing and the ideas you have for the definition. You are now going to return to your groups, the original photos you started with, and you're going to add any new information, and I'm going to give you a scenario card, and you're going to solve it given the conditions. You're going to figure out the speed you're going and the braking distance for that scenario to see if, according to that scenario, you're driving safely, and if you're not, how can you fix that safety? I'm also going to start explaining the next project that we're doing. There's going to be an extension. You're going to take something that resembles a car and you're going to map it out using tape on the floor. And you'll see that in a second. So this is an example of what I'm talking about. I got my original car back up here and I traced it. And then I made it nighttime. Oops, that didn't work. I put the car back in. Now you're going to see what you're going to do for the project. So you're going to identify the distance for the low beams. Then you're going to identify the distance with tape for the high beams. And then you're going to measure out the speed in feet per second distance. And then you're going to measure out the braking distance. So again, you're going to measure out the headlight distance for the low beams and the high beams, and then also the feet per second, and the stopping distance for those speeds are up there to remind you. Also, we're just going to, because everything's in feet per second, we're just going to do a 1-to-1 with centimeters so that we can easily see it with tape. You're going to put tape on the floor. And the important part is to see the ratio comparison of the stopping distance or the feet per second compared to how much headlight space you're given. Further directions will come, and this is the end of the video.